Ladies and gentlemen, welcome to this panel. And this panel is entitled, I'm very excited about this panel because it has been a recurring question during the conference, that is our ethical responsibility towards certainly our environment, certainly the environment, our earthly environment, but increasingly we're finding, and in this conference we have heard increasingly this term of galactic environment. Is the environment of outer space different from our earthly environment, and does responsibility change in relationship to this other environment called the galactic environment? And we're very lucky to have distinguished Professor Raymond Lebeau from the St. Louis University, who has a slide presentation. He's going to give us a slide presentation around and on this question. So please welcome very warmly Professor Lebeau, and we'll get started right away.
First, I'd like to thank the organizers of the conference and all of you for having me here today to speak. I am not a philosopher. I am an aerospace engineer and a planetary scientist. I do not study philosophy. I am going to give you a perspective coming from my background. But the simple fact remains that when you're confronted with the mysteries and the many curiosities of space exploration, I think everyone waxes a little philosophical at times when they're doing that, because you're getting a very different perspective on what the world looks like and what the universe looks like. And so that's where I feel like there's a strong tie between what we do in astronomy and what happens in philosophy. Because a lot of philosophy is about looking at things in different ways and finding different points of view to understand better how we think and how we behave. And we have the same kind of thing in terms of thinking about space. There are a lot of different perspectives that one can take when thinking about the exploration of space and understanding our role in space and in the space environment. And so this first image I have up here is one that you may or may not have seen. It was a big deal about 5 months ago. It was one of the first images released by the James Webb Telescope. And the James Webb Telescope is the latest space telescope to be put in operation. And its basic goal is to explore the depth of space and to begin to understand further understand how the universe exists as it does. And this particular image is one of hundreds and thousands of galaxies scattered back through time. The specific focus of this image is actually on a particular cluster of galaxies, which has a very exciting name of SMACS 0723. We come up with very exciting names for things in astronomy a lot of the time now, because when you're discovering thousands and thousands and millions of new things over time, you kind of run out of names after a while. So we just start putting letters on there and numbers and working with that. But this came out of what was known as the Southern Massive Cluster Survey. And so that's where the SMACS comes from. And this is actually as I said, a small galactic cluster, which is basically a series of galaxies that are gravitationally connected. And so they tend to stay together where they are as they move through space. Now, there's a lot of other galaxies in here that were in the way, so not everything you see in here is part of that particular cluster, particularly with very tiny objects, for example. Those are much further back in time and distance, we think, because again, when we're looking back at these objects, we have to remember that we only can see things as fast as light travels. And so these particular objects, the main ones that we were aiming for, are about 4.5 million light years away. And so this is, billion light years away. And so this is something that's kind of a different viewpoint. So what we're seeing in this image no longer exists. And this is one of the basic challenges we face when we think about our role within a galactic or a universal scale, is that a lot of what we know about the galaxy, a lot of what we know about the universe is fundamentally no longer true, because we cannot get that information soon enough. Now, again, this is just a small segment of our universe. In fact, if you're curious, if you went outside tonight and looked at the night sky, and you took a grain of sand and held it up about arm's length in front of you, that's about the area that's being covered by this image. It is a very small fraction of the overall perspective in the sky. And so we have to think about that as well. It's very difficult to imagine these kind of scales. They are scales that are beyond usually the things that we even begin to think about. So coincidentally, about the time this image came out, I was actually not that far away. The main event where they're introducing these things was at the Goddard Space Center in Maryland in the United States. And I just happened to be 20 miles away at the Applied Physics Lab at Johns Hopkins University, where we were doing a very different discussion about space and the exploration of space. And what we were talking about is developing the next generation of unmanned missions, satellites and probes and landers that we wanted to send to the outer solar system, which is beyond the asteroid belt. So we're looking at Jupiter, Saturn, Uranus, Neptune, Pluto, Kuiper Belt objects, things like that. And so that was our focus of our discussion. And these are daunting challenges. And from a human perspective, they're very long-term challenges. A project such as a mission to Uranus or Neptune, that will take 3-4 decades to complete. The odds are many of the people who are starting work on that project now will not be around to see the end of that project. And again, it's going to cover 4.5 billion kilometers. So the kind of scales that we're talking about here, even within our own solar system, are pretty large and pretty dramatic. And so I think when we want to start thinking about what is our responsibility from a galactic standpoint, if you want to think of it as being a citizen of the galaxy, we need to have a sense of perspective on what we're actually dealing with. Let's see if I can get this to work. Oh, there we go. Okay. So, let's take a look at our galaxy, because that's what we're talking about. This particular image, over the past 12 to 15 years, there has been a renewed interest in mapping our galaxy. For a long time, we've had a fairly standard picture of our galaxy as a spiral-based galaxy. We have taken photos of other galaxies. Many times when people talk about our galaxy, they show you a photo of Andromeda, which is a different galaxy that's relatively nearby and is also a spiral galaxy. But in the last dozen years or so, there's been a number of projects that have been sent out to kind of figure out what does our galaxy actually look like. And that's kind of a challenging thing to do if you think about it. We're trying to map the galaxy while we're in the galaxy. We're trying to be able to get a perspective of what the galaxy looks like. If we were actually seeing the galaxy this way, we would be millions of light years away above the galaxy. We're obviously not there. This is not a photo, by the way. This is a combination of information that was put together, a number of images that were put together, and then an artist's conception later on top of that. So this is more of an artist's conception of what our galaxy looks like based on the knowledge we have now of where stars are and other features. And the point about this is that our galaxy, or one of the points, it's about 100,000 light years across. Now again, a light year is the distance light will travel in the span of 1 year, 1 Earth year. So even from there, we're using our Earth's perspective to get a sense of what the size of the galaxy is. And if you're curious, the sun, get this to go. There we go. The sun is located right about here. In this version of our galaxy, this is known as the Orion Spur. Now that's a matter of some debate. There's different interpretations of the data. So we've gone and collected a lot of data, but there's different interpretations of the data. So you'll see different images of the galaxy out there that people have put together using basically the same data. One of the big debates is, for example, this one indicates we have 2 major spiral arms, which is this arm here called the Perseus arm. And then over here, running up along the top, we have the Centaurus arm. All right? And those are considered, in this model, to be considerably larger and considerably more dense and have many more stars than 2 weaker arms, which are the Sagittarius arm and the Norma arm that you can see here. So other models of the galaxy say, no, we actually have 4 equally prominent arms in the galaxy. So we don't really know entirely what the galaxy looks like. We have somewhat of an idea, but we're still working to figure out what we are looking at when we look at the galaxy. So this galaxy is known, by the way, our galaxy is known as a barred spiral galaxy because we have this bar in the middle, which here is called the long bar, and there's a galactic bar as well. But right in the middle of our galaxy, there's a long section which has this extended bar region here. Gotta get my perspective here. So right around here. It's hard to see the light in there because it's getting covered up by the screen. So, what we're looking at when we start talking about the idea of a galactic responsibility is that how responsible are we for a structure that's 100,000 light years across and contains hundreds of billions of stars? So even if we want to take responsibility for that, and even if we feel we have an ethical responsibility toward that, we are presented with a challenge of what we can actually do given the magnitude of the scale of our galaxy. So let's step back a little bit further then. Let's take a look at a different level of our galaxy. And this one is shrinking in our view a little bit. You can still see, we still have the center, the bar center here, right here. You can see here we are on our Orion Spur coming off here. And what I'm showing here are exoplanets. So one of the big things that has happened in astronomy over the last few decades is our ability to detect planets around other stars. And at this point, actually this year, it was recognized that there are more than 5,000 verified exoplanets that have been discovered. There's a number of different ways that we discover these exoplanets. There's a number of different techniques. A lot of times we look for wobbles. We basically look for the gravitational effect of the planets circling around their star. And because they're circling around the star, they have a gravitational pull. And so you can detect slight changes in the star's location and brightness based on the pull of those planets. So that's one technique. The most common technique actually now is transiting, where we literally we look at the star and we have enough resolution that we can actually see the planet crossing the surface of the star. And we can actually see the fact that there is a planet blocking part of the view of that particular star. That's how we have found roughly 70-75% of our current collection of exoplanets. Now the thing is, because of the techniques that we use, where the exoplanets are located is actually in a relatively small section of our galaxy. The majority of the exoplanets that we have found are located right in this region here, but we also have some other techniques. This is known as microlensing or gravity lensing, which can actually allow us to find exoplanets further out. So you can see this nice trail of the occasional exoplanet system moving toward the center of our galaxy. And in addition, you can see that there's this particular region here, this triangular region, which is a reflection of the Kepler mission. And the Kepler mission was designed to focus on one particular section of our galaxy and look for planets there. It examined somewhere over 500,000 different stars and was specifically looking for any signs of exoplanet evidence around these 500,000 stars. And it turns out, at this point, of that 5,000 or so number that we've discovered, approximately half of them were discovered as a portion of the Kepler mission. But again, it's not a super even distribution. We don't see much of what's happening across the whole galaxy. We have an idea of what's happening in a relatively small section of the galaxy and where these planets might be. And not surprising, when we think about galactic responsibility, a lot of our focus tends to go to thinking about planets. Because we know we can affect planets. We know that we can do things as humanity collectively that can change the conditions on a planetary scale. As of right now, we don't really have any capability of changing conditions in the sun or in other stars. So at that scale, it's not something that we actually can consider, or it's harder to consider what our ethical responsibilities might be in that direction. But we do know that we can affect things on a planetary scale. And so I think when we start thinking about galactic responsibility, the role of exoplanets and what might be on those exoplanets has a very important role in our understanding of what we should be responsible for. All right, so let's focus in a little further. If we go down a little bit further, again, I said there was this little region here where approximately half of the exoplanets are located in kind of a spherical shape around the Earth. That's about 3,000, 4,000 light years across. So that kind of gives us, in that region, there's probably on the order of 2,000 to 3,000 exoplanets that we know about. And these are ones that are detected in a wide variety of ways. We don't need, some of them are based on ground-based detection. There's a lot of different ways that we can detect exoplanets within this region. But I want to focus on an even smaller region now. So if we go ahead and look at this little green dot right here, that little green dot is approximately what you can call our radio wave horizon. So one of the things that we don't think about a lot is that with the development of radio broadcasting around 120 years ago, and then television broadcasting coming later, about 90 years ago, we have been sending a near continuous signal into space about what Earth is like. Every single radio broadcast, every single television broadcast is broadcast out, well, now that we have cable, not so much, but every single television broadcast is broadcast out into the universe. And it keeps going. It is traveling at the speed of light. So those first radio broadcasts, in fact, have already traveled 120 light years away from our sun. And given that, we can define a small region here. We can say, all right, well, what's that size of that region relative to this region of where we have a decent number of exoplanets? So you can see it's just that tiny little green dot. That's a circle of about 120 light years in diameter, or in radius, 240 in diameter. Now, there's still quite a few exoplanets in there. In fact, there's probably somewhere over 100 systems of exoplanets in there. So we're still making contact, if you were, with other systems and other planets. So the fact that the thing we have to think about when we're thinking about our galactic responsibility is that we are already potentially affecting the galaxy, even though we don't necessarily know how. If there is intelligent life located within this realm where our radio waves are hitting, and admittedly they get increasingly weaker, and it may be hard to detect, but if they have their own organization searching for extraterrestrial intelligence, they're going to be in a situation where it's like, hey, we're getting this signal. The closest system to ours, which we'll talk more about in a little bit, is Proxima Centauri. It's a little over 4 light years away. So it's quite possible that they're just finishing up watching the World Cups from 4 years ago. Well, we're watching the World Cup now, finishing up in 4 years later. So we are already influencing our environment at a galactic scale. Maybe not the scale of the entire galaxy, but well beyond the scale of our solar system. And so this is another aspect that we have to consider when we're thinking about our galactic responsibility. Are we responsible for the consequences of what we are already sending out there? Because we don't know. We don't know what has happened. And in fact, if our signal has gone out 100 light years and changed things, we would have to wait another 100 light years for it to come back to us so we could even know that happened. All right. So we're going to shrink down a little bit more. Here we have what we call the heliopause and the heliosphere. And what the heliosphere is essentially the region which we think is dominated by the sun's magnetic field and by various solar winds that come out of the sun. This kind of defines, in some sense, what the solar system is. So you can see we have the sun here. And then if you go out some ways, you hit what's called a termination shock, which is where the wind, the solar wind coming out of the sun, slows down to what we consider a subsonic speed in the context of the interstellar medium. And then a little bit further out, you get what's called the heliosheath. And the heliosheath is really kind of the outer boundary of what we can consider our solar system. Once you pass the heliosheath, you are actually in what we would call interstellar space. So similar to the fact that we know that the atmosphere ends as you go up out into space, but the definition of it is a little bit fuzzy. The same thing is true of the heliosheath. So as we hit that heliosheath, we are actually putting objects for the first time in what can truly be called interstellar space. The two objects that are arguably in interstellar space right now are Voyager 1 and Voyager 2, both of which were launched in the late 70s. And so they have been traveling for over 40 years into outer space and are now just beginning to reach, or in the case of Voyager 1, just crossing the boundary of what we could call our solar system. They are the first physical things that we have sent from Earth that have achieved this status. And so obviously with these physical items, the potential for affecting the galactic environment becomes more present and more real. These objects can actually change things physically. They're a physical object. They can encounter things. In fact, the direction of Voyager 1 and Voyager 2 is to go to our nearest neighbor, Proxima Centauri. So in fact, we are hoping that these objects, in a long time in the future, will actually be able to create change in our galactic environment. All right, so speaking of Voyager, we're going to keep narrowing down here. We have this series of images, which were known as Voyager's Goodbye to the Solar System, and among other names. And so it's an image of what our solar system looks like in relative perspective. So these were pictures taken by Voyager 1 as it was heading out well beyond Pluto and heading out to leave our solar system. And so you can see the tiny little images here that it took of our various planets out to Uranus and then Neptune, and then Earth and Venus. You can see the EV over here next to the sun, and then there's Jupiter right over here. So this is the region of space that we can say we have been exploring with a relative degree of thoroughness over the past 50 years or 60 years. And you can see Neptune is located at about 30 AU, which is called an astronomical unit. The astronomical unit is the distance between the sun and the Earth on average. And so if you want to put it in different measurements, we can talk about it being 4.5 billion kilometers to reach Neptune from the sun. We can talk about it in terms of Earth radii orbit, the AU, which is about 30. Or if we want to go back to light years, we can refer to it as 0.00047 light years. Now remember, our galaxy is 100,000 light years across. So this is orders of magnitude smaller. Where we have actually managed to physically explore space is several orders of magnitude, well, actually more on the order of 10 orders of magnitude less than the size of our galaxy. And if you want to go to human exploration, it gets even smaller. Human exploration is, well, the moon. We are working to get back to the moon right now. The Artemis launch recently went further than any other spacecraft designed to carry humans. But it's still only talking about few 100,000 kilometers. And if you want to think about it in terms of light years, that gets so small, we tend to talk about light seconds. It's on the order of 1.2 or 1.3 light seconds to get from the Earth to the moon. So this last shot down here in the corner, by the way, is a shot from Artemis. That's the spacecraft there. Looking back, it's past the moon, and it's looking back toward Earth. So this is about the farthest perspective we have in terms of our own human participation in space exploration. All right, so where does that put us? Where does that put us in terms of thinking about our galactic responsibility when in fact the scale of our activities is so small relative to the size of the galaxy? And so I think that's where we have to start when we are thinking about, do we have a galactic responsibility from an ethical standpoint? And what would that be? Because the area we operate in is basically our solar system. And what I have up here are a few examples of different types of solar system missions that we have done. The one in the upper left is the Venera, is actually a model of the Venera mission, which the Soviet Union launched to Venus and landed on Venus. We have one of the Mars rovers, I think it's Spirit over here, that's doing some excavation and studying of the Mars surface. And the last one over here is the Cassini-Huygens mission, which was sent to Saturn. And it was a combination of an orbiting mission, so the bulk of this is based to do orbits. But this section right over here, if I can get this to work again. This section right here, very hard to see. I'll just go ahead and point to it. This section right here, this was actually a probe that was dropped into the atmosphere of Titan, which is the largest of Saturn's moons, and is unique because it actually has a significant atmosphere, along with having significant weather cycles. It has clouds, it has rain. It just doesn't happen to be water. It's not hydrology. It happens to be methane, ethane, and similar chemicals. And that probe, in some sense, is our farthest, our most distant situation where we have actually changed the environment of a planet itself, or in this case, one of the moons of Saturn. Because we dropped that. It is now sitting on the surface of Titan. It will be sitting on the surface of Titan for many years to come. And it's not the only case. Obviously, we have left a number of things on Mars. We have left a number of things on Venus. We have left a number of things on the moon. Slowly, we are creating garbage all over our solar system. And so one of the questions that comes up with that ethical responsibility, again, how do we view this? If we are leaving things scattered about our solar system, how do we feel about that? How do we consider that from an ethical standpoint? Is it appropriate for us to drop these things or leave these things, or in the case in particular of the Mars missions, actually alter the environment in significant ways? So again, we have our image over here, but this image with the green circles, and again, I think I'm just going to point to it, this image with the green circles is actually the result of us using abrasion to grind away the upper surface at Mars. Now, for the record, this is a false color image. It doesn't look that bad color-wise if you look at the real image. But still, the grinding is there, those circles are there, and until a big old dust storm comes by, they're going to stay there. Likewise, this was from the failed Mars polar lander. These are images that we think may actually be where it actually ended up. This is the Mars polar lander here. There's a lovely blast zone where it failed in terms of its landing. And then the parachute from the Mars polar lander is located here. So in terms of a bigger perspective, the Mars polar lander itself is here. The parachute, we think, is over here. This is stuff that's going to be there and going to stay there. And even as humans go and explore Mars, the odds are they're not going to try to clean that up. That's not what their primary responsibility is going to be. So what this leads to my mind, is that if we're going to think about our galactic responsibility and the ethics of our participation in the galaxy, we kind of have to start with how we are treating our own solar system. Because this is where we've actually spent a fair bit of time thinking about how we want to manage our galactic environment, our local environment, our solar system environment. And so there's a number of documents and a number of regulations and policies that have come out designed to help guide our understanding of how to be ethical in terms of exploring space. One of the big ones is the UN's Treaty on Outer Space, which has a very long title, which I'm not going to read. But this treaty basically is an agreement between many of the nations on Earth on how space should be explored. And from the perspective of our galactic environment, or our solar system environment, a key portion of that is in the 9th article, which says, parties to the treaty shall pursue studies of outer space, including the moon and other celestial bodies, and conduct exploration of them so as to avoid their harmful contamination and also adverse changes in the environment of the Earth resulting from the introduction of extraterrestrial matter, and when necessary, shall adopt appropriate measures for this purpose. So the big concern that comes out of a lot of our thinking about how we are going to approach space exploration from an ethical standpoint and from an engineering standpoint comes down to this idea of contamination. The idea of trying to do as little damage, as little change to the environments we visit, and in turn to make sure that the process of possibly bringing stuff back from in those environments doesn't cause undue harm to our environment. So building on that idea, an organization that was founded shortly after Sputnik started the space race, called COSPAR, which is the Committee on Space Research, started developing policies on how to go about exploring space and how to think about planetary protection. So basically, the most recent version, which was just approved in 2021, but they've had various versions of this document going back decades, they basically said there's going to be 5 categories of exploration. There are going to be things, and the focus of their dividing these is in particular the idea of contamination, and particularly the effect on life or the evolution of life. And so the 5 categories, the lowest category is category 1, which are bodies where we think, there's no chance that there's going to be any sort of contamination of existing life, or that if we brought living things from Earth, they'd have any chance of surviving. There's not a lot of bodies that we treat like that in the solar system. A few asteroids, a few moons of other planets, but that's about it. The biggest category is category 2. Most of what we do in outer space falls under category 2. And category 2 basically says, okay, yeah, there's a small chance that we could do a small thing that it might have a small effect, but it's going to be small, it probably won't be super long lasting, and we're okay with doing that, therefore. So most of the missions that we have that go into outer space actually are treated as these category 2 missions. And the category 2 missions don't require us to do anything particularly substantial about it. It basically says we have to go ahead and keep an eye out and kind of think about what might happen, but otherwise, go ahead and do it. So the more severe ones are category 3 and category 4 and category 5. And those are specific to a few systems. Mars, a moon of Jupiter, Europa, a moon of Saturn, Enceladus. And the reason we are interested in those in particular is we think those have the conditions that might lead to the prospering of our biological life on Earth if it were transferred to one of these bodies. And so that presents us with a very different dilemma, because even though we can spend a lot of time in clean rooms and sterilizing and trying to make sure that we are not transmitting anything off our planet that might affect the long-term conditions on another body, we constantly have to run up against this problem where we just can't be that perfect. It's a real challenge to make sure that there are no biological elements in existence in something that we are sending to space. And so for these 3 bodies in particular, we have higher level of categories and higher level requirements of what we do before we send them into space. In the case of the category 3, these are things that are not expected to land on these bodies or interact directly with these bodies, but just orbit them or fly by them. There, we have to try to make sure that the path we take has the least likelihood of actually crashing into the surface, because that's where we're going to start having problems potentially. We also have to make sure that we use clean rooms, that we work on reducing the biomass, and we try to make it as contamination-free as possible. When you move to category 4, you're looking at situations where you're actually going to land something on the planet, or you're going to have the planet move through the atmosphere. In the case of Enceladus, potentially moving through the geysers that we see emanating from inside the body. And in this case, there's even higher levels of requirement that require sterilization, for example, of various parts of the spacecraft to absolutely make sure that there is no biological life that's potentially being transferred. The last version, category 5, actually is because that's the one where we say, okay, what if we're bringing something back onto our planet? And that has the highest restrictions of all, because we want to make sure that if there's a potential for something dangerous, something biological coming from outer space, that we are taking proper care that we don't have to worry about it. Now, it turns out back about 15 years ago when the United States was planning its missions for the next couple of decades, they actually went ahead and said, we're going to try to do higher level categories generally for most of these cases. So they went through and classified all these missions by these categories. But, on the other hand, we also have this. So this was the DART mission. This just happened this year. And in the DART mission, you can argue this is the first time that humanity has intentionally decided to change the space environment. And the goal of this mission was essentially to test out the idea of planetary protection. There's been a number of movies made like this, but the basic idea is a meteor, or asteroid rather, is heading toward Earth, and if it crashes into Earth, millions of people are going to die, mass extinction, all sorts of problems. So the theory that's often presented to deal with this is we fire a rocket into that incoming body. Well, the question is, would that actually work? And so what was done is basically we found an asteroid that had an even tinier asteroid orbiting around it. And we said, okay, we're going to send out a space mission that is literally going to crash into this little asteroid. Not enough to break it apart, not enough to destroy it, but hopefully enough to move it and change its orbit. And in fact, that is what happened. If you look at these two images here, you can see how small these things are because they're tiny little blocks in terms of the resolution. You can't, this is this is a picture that was taken actually as the DART probe approached these objects. So this is much higher resolution. But from ground-based telescopes, you can only see so much. But what they can spot is they can spot this orbiting asteroid. So kind of that big band of light in these images is the main asteroid. The tiny companion asteroid is in the orbit drawn by the white ellipse. And so what they could tell is that after we struck this tiny little asteroid, that its orbit was no longer the same. We could say, well, it was supposed to be here in this blue circle, but clearly now it's here. And so that was evidence that we have actually changed for the first time the orbit of another body in our solar system, or more broadly speaking, the galaxy. So this was a conscious choice to change the space environment. For the most part up to now, it hasn't really been our conscious goal to change the space environment. We may be changing the space environment, but that is not our intent. This is different. Now, again, the scale we're talking about is so tiny compared to the galaxy, it's hard to think about that as being something that we need to worry about in terms of our role in the galaxy. And that's probably true. But the fact remains that this is a sign that as we go forward in the future, we will face ethical challenges. The point behind this is an ethical question. Should we let an asteroid come and destroy the Earth? Generally speaking, most people would say no. That would be considered the ethical decision. But what if our technology, what if our knowledge, what if we as moving out into the galaxy, we are able to influence more than this tiny little rocks going around another tiny little rock? What if we are able to start influencing on the scale of planets or on the scale of solar systems? At that point, we are definitely in a position where the ethical decisions we make in terms of how we approach the galaxy can have massive impacts on the galactic, on the galaxy, and on the universe. So while right now what we think about is actually a very small scale compared to the galaxy, we are beginning to look at some of the same issues we would have to deal with if we were to truly become a spacefaring race that is traveling across galactic distances. So the last question I want to pose, or the last thing that I want to pose up here, is the idea that do we have sufficient knowledge and capability based on this to really begin to think about how we need to be an ethical steward of our galaxy? And quite honestly, the answer is probably no. Our big challenge, or one of the great challenges we have as we go out into space, is that we don't know what's there. Of course, that's the point of exploration. So we don't know right now what our radio transmissions and our TV transmissions might be causing 50 light years away. We don't have that level of knowledge. We also, if you've noticed, take a very Earth-centric view when we start talking about things like life. The reason Enceladus, the reason that Europa, the reason that Mars are separated out is because they potentially have liquid water. And we consider liquid water a necessary precursor for the kind of life we see on Earth. That's not true for every type of life we have on Earth, but for most of it, yes. But we are assuming that style of life. We are considering that style of astrobiology. There is every chance that there are other systems out there, other forms of intelligence out there that do not match our view of life. We don't know. And so whenever we start thinking about how we want to address our role in the galactic environment, we are constantly confronted with the fact that we don't know a whole lot about our galaxy at this point. Again, we are talking about a galaxy that is 100,000 light years across, has 100 million stars, who knows how many planets on top of that. And we are left in a position where we just have to be able to accept the fact that if we are going to continue to explore space, if we are going to continue to go into the unknown, there are also going to be unknown consequences that we may find out many years later, or we may never find out at all. And so I think ultimately that is the most interesting and pressing question about what our ethical responsibility is. Unless we want to decide we are going to not send out any more radio broadcasts or any more television broadcasts, we are not going to send anything out into space. We are confronted with a question that says, we need to decide, are we comfortable with doing things where we do not fully know the consequences of our action? From my perspective, my answer is yes. The exploration of space is something that we need to continue to do. And as we gain more knowledge, as we understand more things, just like what we've done in our solar system, the first probes we sent out, we really weren't thinking that much of planetary protection. We have evolved our understanding of what we need to do within our solar system as we have gone out and explored and learned more. I think the same thing is true with how we should view ourselves from a galactic perspective. As we begin to move more and more out into outside of our solar system, into a more galactic scale, it is up to us to not just learn more about science, learn more about the physics, learn more about the chemistry. It is also up to us to consider the ethical and philosophical implications of what we are doing and incorporate that new knowledge so that we can be better stewards of our galaxy. So that's what I had to say. Thank you very much for listening.
Thank you very much. Thank you very much, Professor Lebeau, for this very exciting, very interesting talk. Of course, we're going to try and have a discussion. I was extremely interested in this idea. I was extremely interested in the type of philosophical paradox. Not only scientific, you demonstrated it scientifically, but I was very interested in the type of philosophical paradox that you set between the question of responsibility and knowledge.
Mm-hmm.
This is it poses a very strong philosophical question. Yeah, are we responsible only for what we know, or are we also responsible for what we don't know, or what we can't know, or the unknown? I'm wondering, just to get us started, I'm wondering if you've ever thought about if responsibility can be redefined differently for the unknown than it is for the known. That is, do we humans, and you as a scientist and as a physicist, as someone who studies the galaxy, and of course the magnitude of our galaxy would inspire a, well, listen, we'll figure it out later, you know. But philosophically, I would like to ask you the question: do you think we can think of a responsibility towards the unknown which would be dramatically different than a responsibility towards what is known? That is, the invention of wholly other values for outer space than for our earthly environment, and what would those look like for a scientist? How would you codify them?
Well, I think with regard to the solar system, we're already trying to do that.
Okay.
Because when we go out, so one of the missions that is on the table that people have thought a lot about is, I mentioned Jupiter's moon, Europa, and we think that there actually is a large amount of liquid water under, several kilometers of ice and rock, and there might actually be essentially oceans underneath that surface. There is no way that we can explore that with enough pre-knowledge to make it a totally safe mission that will not necessarily cause potential changes to Europa. We just cannot get that kind of information. And so I think when you're looking at space, we are already already starting to confront that in terms of how we have to think about these bodies. And I said, one of the things that Kaspars did is they said, we're going to treat these as separate bodies. So we're really creating a situational ethics almost, where we're looking at the particular situation and we are defining a particular situational ethics that may be different from kind of our standard knowledge ethics of things that we know about and things that we think about, but where we have to take each thing case by case and develop a separate situational ethics for those systems. And so we are, I think, fundamentally treating from a philosophical standpoint, we are treating situations where we don't have knowledge differently than the situations where we have knowledge.
Yeah, that's very interesting philosophically, because what you're saying, if I translate it to my lexicon, what you're saying is that space ethics, or if we can talk about space ethics, that would mean an ethics of radical particularity, singularity, case by case, as opposed to our usual way of thinking ethics as being universal. Here you would have to figure out an ethics for each particular case, each particular action. I just want to signal that at 4:30 there's going to be a very interesting workshop by an engineer, Youssef Saed Al-Amodi, which will be on, who is present right here, which will be on risk mitigation and the sustainability of space exploration. So he'll be dealing also with this question that you dealt with in your talk about treaties and the possibility of formulating an ethics and legislation. These are all questions that are going to be posed. I have other question, but let's see if we want to react from the public. Yes. Sorry, there's a microphone.
It's a wonderful lecture, Doctor. I would ask a very quick question. Is the responsibility towards our environment on Earth is the same as preserving our responsibility towards the galaxy, regardless of entering our knowledge of the subject? Because we always think the same, but with a greater technology. So if you can comment on that, please.
So I think that our ability to make ethical decisions on Earth is a result in part of the large body of knowledge that we have about how we think about Earth. And I think it's difficult, as we were kind of talking about, to be able to separate out the question of the amount of knowledge we have about a topic and our ability to come up with a reasonable understanding of the ethics that they present. Now, there are certainly things that we can carry on universally. For instance, there's a general ethic that if we were to discover some form of life on another body, we would not destroy it. All right? And that's more of a universal type of view of ethics and philosophy, is saying this is a line that we will not cross. Now, we haven't encountered that yet, of course, so we don't know how we will actually react when that occurs. So I do think there are certain things that we can carry out, even not knowing very much about what we are about to encounter, and use those universal truths or near universal truths that we have on Earth and extrapolate those out to space. But I think we reach a limit, because we reach a point where we just don't know enough to know what the ethical decision would actually be. Until we understand things well enough, we can't really say, is this the ethical decision? Is this the right decision? If you look at much of medicine, a lot of things we do in medicine, if you didn't know what the purpose was, would seem unethical. I'm going to cut this body open. Okay, well, that's not usually something we would consider as an ethical act, except for the fact that we know that we're doing that to save or help prevent disease or otherwise make the person more healthy ultimately. But the basic act is not inherently or obviously ethical. And so when we're dealing with an environment that we know very little about, how do we know that the thing that we think is the ethical thing to do is in fact the best thing to do in that situation? So we are always going to be confronting that issue as we move out and explore.
Any other questions from the public? You were talking about limit right now, but so I suspect the limit would be the destruction, of a planet or even an asteroid, but from where do you draw that limit then? I mean, if the ethical horizon here is to venture out into the unknown, and you stress, and of course we all agree, it would be non-ethical to stop space exploration altogether. But if the ethical horizon has changed, and the factor of the ethical horizon here is the unknown, then where do you draw a limit? Where are we going to draw? From where are we drawing a limit?
Well,
and an ethical limit on top of that.
Well, I would say that, again, we are constructing the ethical limits primarily based on how we view our ethical limits on Earth right now.
Okay.
And we are saying that, all right, these are things that we are most worried about. The fact that we're focused on contamination, the fact that we're focused on biology and astrobiology and the potential for life is a reflection of our personal ethics, the fact that and the ethical systems we have on Earth. And so I don't think we can totally get away from that ethical viewpoint, because that's our basis of knowledge again. But I agree, we face two challenges here. One is that we aren't going to be able to understand the limits necessarily, and we are going to be presented in situations where our understanding of ethical limits may not be an accurate application to what we are encountering. And the second problem is for all we know, we are violating those ethical norms as we stand. We have no ability to know. Eventually, Voyager 1 and Voyager 2 are going to reach Proxima Centauri. 16,000 to 20,000 years from now, they're going to reach Proxima Centauri. We have a record on those. You may not know, there's actually what's called the golden disk. It is a record that was developed, a phonograph record that was put on those tube probes on the assumption that if some alien race were able to capture it and look at it, they could play them and learn more about us. In fact, there's a map of how to get to our solar system based on the distribution of pulsars around the galaxy that would, in theory, guide an alien civilization to where we are. Now, first off, given our move toward electronic music and electronic media, it's not clear that in a couple of centuries we would know how to play a phonograph record. All right? But secondly, if you look at it, it is an example of how we are tied to how we think about the universe and how we think about physics and how we think about science, because that's what we know. It's an attempt to make it universal. The numbers are in binary. There's a reference to a particular aspect of hydrogen, because we assume that everyone will know about hydrogen who could be able to work with this. But even so, if you think about it, take a step back, you look at it and say, okay, unless there's some similar type technology that they use, the odds of them understanding this is really pretty slim. And so we're going to be constantly presented with the fact that we don't know how things are going to be reacted to. So it's quite possible that these things can reach Proxima Centauri. And Proxima Centauri actually has planets. We know that it has 3 exoplanets, one of which we would consider in what's called the habitable range, which means it could have liquid water on the surface. So by our standards, there is a possibility that there is life there, and there is a possibility that there is an intelligent life there. And we are about 20,000 years from now, or maybe in 20,000 years, there'll be intelligent life, and we're just going to drop this thing on them. We don't know how they're going to react. We have no way of knowing how they're going to react. And so while I think we're going to continue to look at our own humanity and our own sense of what ethical behavior is, the simple fact remains that you have to be comfortable, I think, with space exploration, knowing that you may be unwittingly violating your own ethical norms by what you're doing.
Nicholas de Warren, the philosopher, gave a talk at a plenary lecture upstairs, and he was also talking of the problem of communication, the problem of language. And this is what. So what's interesting here is that we've moved from the question of galactic environment to the ethical question of what Nicholas was calling the first encounter, the first contact. I understand. Any other questions? Because apparently I'm being told that, please.
Good afternoon, everyone. I'm just wondering to what extent the ethical boundaries is similar, toward our everyday environment in which we live, is similar to the ethical boundaries toward the outer space environment. And how can our normal people can participate to save the outer environment?
Well, I think for one thing, yes, there are some similarities between how we view our own environment and how we're going to probably treat the environment beyond Earth. There's obviously a much higher potential for effect on ourselves on Earth, because obviously we are immersed in this environment, and so therefore if we change our environment, we're going to feel the effects immediately. Well, if we change the environment on Pluto, probably not going to notice much in your everyday life. But at the same time, I do think there is a role for everyone to play in this process, just like we have many debates and discussions about the trade-offs of how we produce energy, how we distribute resources, how we manage our environment, try to minimize the damage, at the same time allowing us to advance in various ways. We are going to face those same arguments, and we already currently face those same arguments. The fact is that probably within the next few decades, there is a good chance we are going to be landing human beings on Mars. And that is going to be our first human exploration, direct human exploration of another system, and another system which in many ways has the potential to support life. And we're going to have to decide, humanity as a whole, what do we want to do with that situation? Do we want to explore it? Do we want to colonize? Do we want to terraform? Do we want to try to make a second Earth? And there are philosophical impulses toward that direction, but there are also the same impulses that we see on Earth of wanting to preserve and maintain things all around us. And so I think within the next, few decades, we are going to be beginning to reach that ethical question and that boundary where we as a society and we as humanity have to think about what kind of way do we want to approach our expansion into space. And I think that's going to be something that will be available for everyone to participate in and make their voices heard, or hopefully so anyways.
Thank you very much, Professor Lebeau, for a very exciting workshop and talk and lecture. Thank you very much, and I invite you now to join me in thanking Professor Lebeau. And so we are going to move back up to other panels. There's a panel upstairs entitled Exploring Inheritance and Knowledge. There's a workshop on risk mitigation and the sustainability of space exploration right here in the knowledge workshop, and the future of personal relationships in the age of AI, that's in the exploration workshop that's across the thing. Thank you very much, Professor Lebeau, and enjoy the following panels. Thank you. That was great. That was very, very interesting.
Well, I hope people got something out of it.
Oh, no, definitely. And I thought it was extremely, extremely interesting.